Today we're going to talk about the converse of the Pythagorean theorem. Kevin, can you read this for us? What happened? Oh, go ahead. So he picked you today.
We have seen that the converse of a theorem is not necessarily true. However, the converse of the Pythagorean theorem is true. It is stated below as theorem 8.3.
Right. We know that the converse of theorem is not necessarily true, right? But for Pythagorean theorem, guess what? It is true. So here it is. Here's the theorem, as you expected. It says, if the square of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. Okay. So write this down. And of course, fun part is proving this, right? So, yes it is. Okay, so go ahead and write this down, and we'll wait for you, okay? So, to prove this, what we're going to do is we're going to do a little something interesting. I don't know if we've seen this before. I don't think we have. We're going to draw another triangle, but this time, do we know that ABC is a right triangle right now? No, that's what we want to prove, right? But we are going to actually draw a right triangle with sides B and A. Is that okay? So you know how this triangle that we had before had a side of A and B as its side? So we're going to draw, look what it says here. We're going to draw a right triangle, EFG, with the leg A and B.
It's not fair. Oh, okay, never mind.
We could do that, right?
Yeah.
Could we, right? Can you copy a segment? Yeah, and then can you, from that point, can you draw a perpendicular line to it? And then within that perpendicular line, could you copy that segment there? A. Right? Yeah, and then you connect EF. Is that okay? We could do that. We could construct a triangle, right triangle, not any triangle, right triangle with the sides of the leg being A and B. Okay, if we do this, what can you tell me about D? Raise your hand. Oh, actually, don't raise your hand. I'm going to call somebody random. How about Josh? Let me hear your hint. Josh, since we have drawn a right triangle, what do you know about the size of the right triangle? We just learned this yesterday. Yeah, A squared plus B squared is equal to D squared. This time it's D squared, right? Would you not agree? Because we constructed a right triangle here, right? Using the side A and B, right? So this is what we get. Whoops. Move it down. So we get D squared is equal to A squared plus B squared. Is that okay? That's just because of the Pythagorean theorem, right? If that's true, well, look at what's given to us. What do you know about this triangle that was given to us? Even though we don't know it's the right triangle right now, but we do know something about their size, right? It has some sort of relationship, doesn't it? What do you know about the triangle that's given to us? C squared is equal to what? A squared plus B squared. So take a look at this. Look, if D squared is equal to A squared plus B squared, and if C squared is equal to A squared plus B squared, what can you tell me about D squares and C squared? How about Jonathan? They're equal. You're right. We kind of have to. So they sort of did this as a key step of. Let's take a look at this real quickly. Turns out. So you know how we had D squared. We basically get using transitive or something like that. D squared is equal to A squared. I mean C squared. Isn't that what we get from this, right? So how do they get C equals to D? Well. How do you solve for one of the variable when you have something like this? Yes. How about Jet?
You take the square root.
Yeah, you could take square root both sides, and whenever you do, you have to write plus or minus. So let's take a square root. That's a shortcut. Square root both sides. Okay. We get plus or minus on the right side, so we get D is equal to plus or minus C. Correct? Because they cancel out. Remember, square root and the squares they cancel out. So we get D is equal to negative C, so D could equal to negative C, or D could equal to C. Turns out we could actually get rid of this one. How can D be? Why is it that we could get rid of D equals to negative C? Hold on. How about Pomon? What do you think?
Oh, because a side can't have negative.
Yeah, these are all sides, aren't they? So sides can't be negative. So D must equal to C. That's how they got right here. D equals to C. Is that okay?
Yeah.
Are we good with that?
And you just do like inductive.
Oh wait, inductive proof to solve this?
Oh, you want to use? What do you mean? Okay, but Kevin, can I do it this way for now? Let's just go on with this. All right, then, since C is equal to D, what can we say afterwards? Well, look what we have here. Now look, my D is equal to C. Isn't that right? So Esther, right here, up here. What do you think? If D is equal to C, what can you tell me about this triangle ABC versus triangle EGF? Yeah, so we just said that D is equal to C now, right? We have just shown why D is equal to C. Look, if D is equal to C, in other words, if the length of D is equal to the length of C, what can you tell me about triangle EFG versus ABC? These two triangles are what? They are? Are they similar? Actually, they're a little bit more. They are congruent, aren't they? Because look, A is equal to A, B is equal to B, C is equal to D. By what theorem are they similar or postulate? Side. By side postulate, aren't these two triangles similar? I mean, congruent? Question.
Wait. How?
Okay, I'm gonna give you time. Okay, talk to your group. Go ahead, talk to your group. Hold on, talk to your group first. Go ahead, talk to your group. So, Amy, do you see how we get by side postulate, right? The two triangles are not similar. They are congruent, aren't they? So, since they're congruent, what can you tell me about angle C and angle G? How about Tony? They're congruent, and so angle C must be what kind of angle?
Right angle.
Right angle, right? So if angle C is right angle, what kind of triangles do you have, guys? You have a right triangle. And Kevin's question is, could we do this using inductive proof or proof by contradiction, right? Is it okay to do it? Yes. Okay, that's fine. I think it works out pretty well. Any question on this? But do you see how this works in just proving it directly, right? Okay. So let's move on. So it's good to know some common right triangle length. Anybody know one? How about? Yeah, Samantha? It's not here. Sorry. How about Eric? Do you know of any three length of triangle that gives you a right triangle? That's right. So turns out if you have 3, 4, 5 length, it will give you a right triangle. If you don't believe me, we could use the theorem that we just used, right?
Wait, but
You need to write this down.
No, it's okay. Just remember 3, 4, 5. Just write that down. 3, 4,
so
5.
if we draw it in any order, if we draw 3,
Yeah.
4, 5, it's always
Yeah, it's always going to get your right triangle. Because, think about this. What is 3 squared, class?
9,
What is 4 squared?
16,
What is 5 squared?
25.
So what's 9 plus 16, which is 3 squared? Yeah, see, it gives you 25.
What?
Exactly. This is, yeah, this, yeah.
If you measure and draw it,
Yeah, exactly, yeah. So if you have, right, think about it. If you have a segment that are 3, 4 by 5 by that unit, it's always going to get you a right triangle if you form a triangle. This is always going to be true. And just like Yechen said, this is because of the theorem we just proved, right? We have, right, if the squares of one side of what? Triangle is equal to the sum of the squares of the other two sides, and you have a right triangle. So does that, you see how that works out? Okay, of course, multiples of 3, 4, 5. Do you think 6, 8, 10 will work? Yeah. Okay. Of course, multiples of these will always work. Some other ones, they tell you these are, they say these are common. I haven't really seen them, but there. What about 5, 12, 13? That thing also works. You can verify. If you do 5 squared plus 12 squared, it will equal to 13 squared. Actually, I've seen this before. This is good. I haven't seen the other two, 8, 15, 17, and 7, 24, 25. But they are, but nevertheless, okay, so write these down. I'll give you time to. No, you don't have to memorize. Only thing you should memorize is like 3, 4, 5. But the other one, just know that these are some common right triangle length. Is that okay? All right. So I'll wait.
All of it, the black ones did.
You don't have to. The black ones are just multiples of it, so you don't have to write it. Just write the. Here, write the red ones then. Here you go. Okay, you good? Nicholas, why don't you read this for us? Okay, stop right there. So, using these theorems, we could determine whether triangle is right, acute, or obtuse with the other theorems that we're going to be talking about. There's going to be 2 other theorems, okay, other than this. But it's going to be very similar to this. So, yeah. But remember, this is important. In each theorem, C is the length of what? The longest side of triangle ABC. Okay. So, take a look at this now. Give me a sec. So here's our theorem that we just talked about, right? If you have a triangle ABC, okay, if you have C squares equal to A squared plus B squared, you know that angle C is what? 90 degrees. Therefore, you get a right triangle. Is that okay? Now, the two other theorems.
Is that the theorem?
Yeah, and you'll actually be proving this for your homework tonight. So take a look at this. Take a look at. Now, what do we say about C?
It's not little.
It's the longest side.
Longest side, right? So if C now, can somebody guess what would happen if C happens to be this way instead of equal to A squared plus B squared? If C squared is less than A squared plus B squared, I want you to all talk about this with your group. Go ahead. What do you think is going to happen? Go ahead, everybody think about it. So what do we say about C of this triangle? C is the longest side. So what can you tell me about this? What if C squared was less than A squared plus B squared? Brandon, can you guess what might happen? No? Guess, Sarah? Okay, hold on. So Brandon, if C squared was equal to A squared plus B squared, right? If C squared was less than A squared plus B squared, compared to the triangle on the left to the triangle on the right, what do you think about C? Do you think this C on the right will be bigger or smaller than this C right here?
Smaller.
So what can you tell me about this angle that used to be 90? Do you think that angle will be, the angle opposite of that C, would it be less than 90 or more than 90?
Less.
Do you think it'd be more than 90? Okay, think about this. If we had a right triangle, right? Look at this triangle right here, Brandon, right? We know that this C, when C squared is equal to A squared plus B squared, we said that it becomes 90 degrees, right? Now, if C squared is now less than A squared plus B squared, do you think the C will be longer than the C on the left? It would be shorter, wouldn't it? So if this is shorter, what do you think about the angle opposite of the side? It used to be 90 right here, right? Do you think it would be greater than 90 or smaller than 90? Smaller. So that's the end result. C is going to be less than 90. Therefore, what kind of triangle would this be? Acute. Does it really become an acute triangle? What about, don't we have to worry about A and B?
No.
What if A and B are 90 or obtuse? Is that, it cannot be. You're right. Why not? Who can tell me? Hold on. Who can tell me? How about, Yvetta, why would A and B, why can't A and B be 90 or greater than 90?
Because then that would be more than 180 degrees.
Well, C is acute. B could be acute and A could be right 90 degrees or obtuse. Why can't that happen?
Because then at 90 degrees angle plus another angle would be much.
No, what I'm saying is, okay, here we do agree that C is going to be less than 90, right? Just because C is less than 90, does it guarantee that you're going to have an acute triangle? A could be 90 and B could be acute also. Right? It could be 90, 60, 30 or something like that. Okay, think about this as a group. Go ahead. Everybody think about this. Why can't... So, I'm telling you that just by knowing this length of AB, which is C right here, if C is less than A squared plus B squared, and the angle became acute, right? That guarantees that you have an acute triangle. You don't have to worry about angle A and B. Why not? You better?
Because C has to be the longest.
Yeah, C is the longest side in this triangle, correct? And if the longest side, the angle opposite of the longest side is less than 90, guess what? The other two must be less than 90. Less than 90 also. Right? Because C is the longest side, right? If the angle opposite of the longest side is less than 90, the other ones also has to be. Correct? All right, what would happen then if C is greater than?
Obtuse.
Oh, sorry. Thank you. If C squared is greater than A squared plus B squared, yeah, you guys could all guess. Guess what's going to happen? Yeah, you're going to have an obtuse angle, 90, C greater than 90. Therefore, you have what kind of triangle? Obtuse triangle. Is that okay? Like I said, you're going to be proving these for your homework tonight. Okay. But there's one theorem that's going to be really helpful for you. Hold on. And let me show you the theorem. Okay, do you guys remember the side inequality theorem? You do? Go ahead. Look for it in your notes. Go ahead. What do you think? Because that's going to be helpful for you when you do your homework tonight. Side inequality theorem. Okay. Actually, I have it here for you. Okay, you guys remember this? Side. Who would like to read this for us? How about Andrew? Yeah.
If two sides of one triangle are congruent to two sides of another triangle, but the third side of the first triangle is longer than the third side of the second, then the included angle of the first triangle is larger than the included angle of the second.
In other words, look, if A, B, and D, E are congruent and B, C, and E, F are congruent, right? And we told you that AC was longer than DF. What can you tell me about angle B and E? Which one's greater? Angle B, right? Do you think that's going to be helpful for us to prove these theorems? Look, what are you going to compare? You're going to compare the right angle with C, where it's smaller. And then this one, you could compare with the 90 with C, where it's greater, right?
Yeah.
Does that make sense? So this one has to be greater than 90. This one has to be less than 90.
All three or up to or two?
Question?
Are we talking theorem 8 and 4 and
Yeah, so these are going to be on your homework tonight, so you'll find out. Okay, so using these theorems, let's do some examples, okay? Because what I'm going to do is I'm going to give you some length of triangles, and I'm going to guess what I'm going to ask you. Yeah. Tell me whether or not you have a right triangle. What else could you have? Obtuse triangle or acute or an obtuse or right triangle. So you could now when I give you three length of the three sides, right? Length of the three sides, you should be able to tell me whether or not I have a right triangle, acute triangle, or an obtuse triangle. Does that make sense? And what are you going to use? These theorems. Does that make sense? Okay, let's write it down. I'll show you in a minute. Here we go, guys. I have the length. So they're the length. There are 5 of them. 20, 21, 29. Look at B. The same, really similar. 20, 21, 30, right? C is 20, 21, 28. Okay, and then D and E are a little bit different. I put a star on E. Let's see if you can figure this out. So can you tell me what kind of triangles I get if I have these segments, right? These are the length of the 3 segments that you get. You should be able to tell me whether I get a right triangle, acute triangle, obtuse triangle, right, and so forth. Go ahead, everybody try. You could help each other out too. Okay. You can help me with the first one. Grace, what did you get for first one? What kind of triangles did you get? You're right. So which one did you use as your C? Which number did you use as a C? 29. Because remember, C is the longest side of the triangle, right? So this is a right triangle. Okay. Okay, for B, I told you, if you did A, okay, thank you. If you did A, you don't need to do really B and C because look, B and C, they had 20, 21, 20, 21, right? Now it's 30. When it was 29, it was a right triangle. What do you think if that longest side is 30? Amy, what do you think? What kind of triangles do you think you would get?
Obtuse.
Yeah, this is an obtuse. Right? Does that make sense? What about then for C, Chan? If it's now instead of 29, if it's 28, it's an acute, right? Okay. What about for D, Eamon? This one you just have to actually do it. Were you able to do this one? I'm sorry. Acute. How many people agree with Eamon? It is correct. It's acute. Wait, is this acute? Oh no. This is not acute. So Eamon, you want to change your answer? It's obtuse.
I don't get it.
I get it.
Okay, you have a question, Andrew? Did you have a question?
Wait.
Yes.
We at 25 and 36,
Oh wait, I get it.
right? Then equals 61, right?
And 8 times 10 equals 64.
Yeah, and the longest side is bigger.
No, you want
Are you
to.
supposed to square the longest one?
Yeah.
So 8 squared is 64, genius.
Oh yeah, it's obtuse.
If you get this,
Snap.
what do you get?
Oh.
Be careful. You have to square them all. Any question with this? You get an obtuse triangle, don't you? Yes? Pass. Are we okay? Alright. You just have to plug it in. You all know how to multiply 2 numbers together, can't you? Don't you? Alright, now what about the last one? I put a star on this one. How about Michael? What did you get? What?
Not a triangle.
You're right. This is not a triangle. So this is a little bit kind of a. Right. So be careful, guys. Guys, you don't just class. You don't just blindly plug this in. You don't get a triangle with 4, 5, and 10 as a length. So Michael is right. Because, look, if this is 10 right here, here's 4, and here's 5, are they even going to reach?
No.
Even if I make this other one 5, would that give you a triangle? Remember, in order for these lengths to form a triangle, some of the two sides must be greater than the third side. Okay, so please be careful. So I just put that in just to sort of, I want you to be careful, okay? You gotta have a triangle to right first to be able to tell whether it's right or obtuse or acute. Right? Any question? Can you do something like this for your homework tonight?
Yeah.
All right, good.
So